Hi, everybody. Last time we were talking about writing chemistry equations. This time we are going to talk about balancing chemical equations. And the reason we have to do this is because of something called the law of conservation of matter. But before we get into that, let's talk about what a scientific law is. A law in science is a description of how matter behaves. Now, this is determined by countless observations by a multitude of scientists over many generations of people doing science. This is not a man-made law. This is not something that a group of people got together and said, hey, I think we should do it this way. It is uncovered by scientists. This is a way of saying this is how nature behaves. We are not warping nature to our will. We are just basically discovering how nature acts naturally, and we have to obey the laws of nature. And that's why we have to do some of the things we have to do in science, because breaking these laws are not an option. The law of conservation of matter, also sometimes called the law of conservation of mass, says this: in an isolated system, all of the matter within the system stays the same. Another way of saying that is, if you have a chemical reaction, all of the mass of the reactants before the reaction are going to be equal to the total mass of the products after the chemical reaction. If you keep track of every atom before the reaction occurs and every atom after the reaction occurs, the mass of everything is going to be the same. There is not going to be any mass that is lost. Nature does not make matter disappear. Another way of saying this is that no matter can be created or destroyed, despite what it looks like when you watch Harry Potter wield his little fabulous magic wand, and it looks like things go poof and disappear. Even Harry Potter cannot make this disappear. It has to go somewhere, and it has to, when things appear, they have to come from somewhere. Even in Professor Snape's potions class, you have to obey that law of conservation of matter. So every atom before and after a chemical reaction must be accounted for. So for example, if we look at this chemical reaction, which is the burning of methane, which is a common fuel for household stoves, if you happen to have a gas stove, and it is burned in oxygen, if we count, there are 1 carbon, 4 hydrogens before you start, and then 1, 2, 3, 4 oxygen molecules before you start. At the end, there is going to be 1 carbon, the black molecule represented here, 4 oxygens, 1, 2, 3, 4 oxygens represented by the red molecules here, and 4 hydrogens represented by the white molecules here. And every single one has to be accounted for in that chemical reaction. They can't magically appear, and they cannot magically disappear. This is the bookkeeping of chemistry, sort of like balancing your checkbook. Not necessarily the most fun time you ever have, but it is something we must do in science. Now, how we do this is by adding something that is called coefficients. When we balance a chemical equation, this is the process of adding these coefficients to a chemical equation in order to obey that law of conservation of matter, that law of conservation of mass. And we do this by adding large numbers in front of the chemical formula for the element or the compound we talk about. We always balance by changing these big numbers, these coefficients. We cannot and never change subscripts. We never change subscripts. And we never change the bonding involved in order to make something balance. So let's go ahead and do one of these. We looked at this chemical equation earlier. Magnesium solid chemically reacts with oxygen gas to yield magnesium oxide solid. In other words, magnesium is going to burn in oxygen to yield magnesium oxide. Now, how do you balance this? You look at each individual element and you count how many molecules. I have 1 magnesium here, 1 magnesium there. Magnesium currently is balanced. I look at oxygen. I have 2, and that subscript indicates 2. Why did it have to be 2? Because oxygen is diatomic in the air. It always appears as a 2Z. When it bonds, though, only one oxygen atom bonds with one magnesium. So in the compound magnesium oxide, I only have 1. That means this is unbalanced. In order to put it in balance, I can only change it by adding a large number written in front, which is a coefficient. So I can balance it by putting a large number in front, a coefficient. Mentally, what I'm doing is saying 2 times whatever is behind it, very much like multiplying in mathematics, but we don't put the parentheses in. I just put that large coefficient in front. And that says, hey, I get 2 of these magnesium oxide molecules. Now I've got 2 oxygen and 2 oxygen here. Life is good. But now I have 2 magnesiums. How do I make the magnesiums on the left balance? Well, I add a 2 there as well. And personally, I always go through one last time and double check. 2 magnesiums, 2 oxygens, 2 magnesiums, 2 oxygens, and I'm balanced and everything is fine. Let's do another one. We've looked at this reaction in the last talk, so let's go through it. Solid sodium plus chlorine gas react to yield sodium chloride solid. Let's balance it. I've got 1 sodium here, 1 sodium on this side, so they are okay. That's fine. I've got 2 chlorine here, 1 chlorine there. How do I balance those? Well, I can put a big coefficient in front, and that means 2 times the whole package sodium chloride, because that's how nature produces them. And that now gives me 2 chlorines on this side, 2 chlorines on that side. But it messes with the balancing of the sodiums. So now I can put 2 sodiums on there, and we double check. 2 sodiums, 2 chlorines, 2 sodiums, 2 chlorines, and that is good. Now, some people find this a little bit too on the fly, and they need a system. One of the ways you can do this is write down every element on the product side, on the reactant side, and on the product side, and you can count and say, okay, to start with, I had 1 sodium and 2 chlorine, and on this side to start with, I had 1 sodium, 1 sodium and 1 chlorine, and then I multiplied, and then I ended up with 2 and 2, and when I multiplied by 2, I ended up with 2. This writing them all out is something that I only do in more complicated molecules, and we'll use this technique when the bonding gets a little bit more complicated. Seriously, if you can do this sort of in your head, it's faster and easier, but if you like having a systematic approach, please, you kind of write everything out if it is helpful to you. I want to give you kind of an analogy of what's going on, because thinking about molecules is tricky and hard because we can't visualize them. They're very, very small. I am a Wisconsin girl, and bratwurst is part of what we eat here in the state of Wisconsin. But when you go to the store and brats come in a 6-pack and buns come in an 8-pack, yeah, that is a challenge. So if you go to the store and say, I only want to buy 6 buns, but they come in an 8-pack, the people at the store are going to say, well, buy 8, throw 2 out. They're not going to let you take 2 out and like leave them on the store shelf. You're going to be invited not to come back to the store if you do silly things like that. So the question is, if I want to balance my brat bun chemical reaction here, how many of each do I have to buy? So I have 0 leftovers, and you're not allowed to leave half packages lying around the store because that would be just weird. So buns come in 8s, brats come in 6, and how many total brat bun combos will I have in order for everything to work out even? This gets a little bit wacky when the numbers get bigger, so let's dive in. Personally, one of the things I like to look at is the least common multiple. What is the number that both of these will multiply into? Both 6 and 8, what number will they both multiply into? Well, both 6 and 8 are multiples or can be divided into 24. So 24 divided by 8 is 3. So if I buy 3 packages of buns, and 24 divided by 6, if I buy 4 packages of brats, 6 times 4 is 24 brats, and 3 times 8 is 24 buns, I will end up with 24 brats and buns. And you might go, I'm not doing that. There's only me and my sweetie pie eating brats, but that's how the chemistry works. So you understand the complicatedness of this. In the world of chemistry, you cannot just let a couple of these go bad in the fridge. That's not how chemistry works, which is what happens in my house. Okay, let's try another of these. If you feel confident, go forth, hit pause, try balancing this one. N2 plus H2 yield NH3. Now I'm going to go ahead and do this one. I've got 2 nitrogen here. How do I get 2 nitrogen there? I'm going to put 2 there. So my nitrogen now balance. I've got 2 hydrogen here. 2 times 3, I have 6 hydrogen. How do I get 6 over here? Multiply by 3 and then go through it one more time. 2 nitrogen, 2 nitrogen, 6 hydrogen, 6 hydrogen. I'm balanced and life is good. Okay, hit pause. Try this one. But before we go, I'm going to, as we go through more, and we're in the next video, we're going to practice more of these, I'm going to give you some hints. Now, the hints I'm going to give you are definitely guidelines. They are not rules. It's kind of like we're hanging out on the Black Pearl here. And one of the hints that I have found from balancing equations is sometimes helpful to balance the most complex molecule first. So go forth, try this one, and then we'll do it. All right. I am going to start by balancing my ethanol molecule. So if I've got 2 carbons, I'm going to put a 2 here. So 2 carbons, 2 carbons. I am next going to say, okay, how many hydrogens do I have? 5, 6. I got another hydrogen there. So I've got 6 hydrogens. How do I get 6 hydrogens here? I've got 3. 2 times 3 is 6. 6 hydrogens on that side. Then how many oxygens do I have? I've got 1 oxygen there, 2 oxygens there. On this side, I've got 2 times 2, 4 oxygens, plus 3 oxygens. I've got a total of 7 oxygens on that side. How do I get 7 over here? Well, this is a 1, so I'm going to have to make this a 6. 2 times 3, 6 oxygens. And there is my balanced equation. Guys, like many things in life, the only way you're going to learn how to do this is practice. So next video, we're going to come back. We're going to do some more. And then on the study guide, you're going to get lots of practice. See you then. Bye.